everyone, welcome back to NG classes. I hope you all like my previous video, and if it helped you, please do subscribe my channel. And yes, if you want me to discuss any other topic, please comment in the comment box. So today we are going to discuss the concept of exponents and powers. Now you must be thinking why we are going to learn this concept. What's the use of it in real life? So when we are having such a larger number or maybe such a smaller number, just like this, then we can use the concept of exponents or powers so that it will minimize the chances of occurring mistake and we can handle such numbers with ease. Here we will discuss how to write these numbers in exponential form, and we will also discuss how to do the simplification or how to apply the operations when we are having numbers in exponential form. As you already know, when we are having a number like this, 3 to the power 5, here 3 is called the base and 5 is called the exponent or power. We can write it as 3 times 3 times 3 times 3 times 3. Here 3 is repeating itself 5 times. So let's start the discussion in detail. Now let's see the laws of exponents, or also called the properties of exponents. By using this property, we will do the simplifications. So let's see one by one. So the first property says when the terms are in multiplication, that is a to the power m multiplied with a to the power n. Be careful here, the bases are same. Both the bases has to be same, then only we can use this property. Powers can be same or it can be different, doesn't matter. Alright, so when the bases are same and both the terms are in multiplication, then we have to add the powers. So it will result in a to the power m plus n. Alright. For example, if we are having 2 to the power 4 times 2 to the power 5, when the bases are same, then we have to add the powers. So the result will be 2 to the power 4 plus 5, that means 2 to the power 9. Or if we are having minus 3 to the power 2 times minus 3 to the power again 2, so powers can be same or different, doesn't matter. Bases has to be same, then only we can apply this property. So it will be minus 3 to the power 2 plus 2, that is minus 3 to the power 4. Alright, let's move to the next property. Here the next property says when the bases are same and both the terms are in division rather than multiplication, so a to the power m divided by a to the power n, then we have to subtract the exponent. So it will result in a to the power m minus n. Here exponent can be positive or negative, doesn't matter. We just have to be careful that we are subtracting the denominator's exponent from numerator's exponent. So if we are having 2 to the power negative 5 divided by 2 to the power 8, so we will do the subtraction 2 to the power negative 5 numerator's power minus denominator's power, and we will write the result, which will be 2 to the power minus 13. Similarly, if we are having 7 to the power 2 divided by 7 to the power minus 3, again we will do the subtraction of the powers because the bases are same, and from numerator's power, that is from 2, we will subtract negative 3 like this. Alright, and eventually it will become 2 plus 3, and which will result in 7 to the power 5. Now let's see the third property, which says when a is having two different powers, that is m and n also, then we will do the multiplication of the powers. So it will result in m times n or m multiplied with n. If we are having 3 to the power 4 and then one more power we are having, then we will do the multiplication of powers. That means 4 times 2, that means 3 to the power 8 will be the result. Alright, let's move to the next property, and the next property says when a to the power m is there multiplied with b to the power m. Be careful here, bases are not same, here powers are same. So when the powers are same, we can write it together, a multiplied with b, and both are having power m. Alright, if 2 to the power 7 is there times 3 to the power 7 is there, here 2 and 3 bases are not same but the powers are same. So we can write 2 multiplied with 3 and both are having power 7. By giving this bracket, we are representing combined together are having power 7. Alright, let's move to the next one. So the next property is also same. Here it says when two terms are in division and the powers are same but the bases are not same, just like the previous one, we can write it together. We can write the power by giving the bracket. For example, if we are having 7 to the power 2 divided by 3 to the power 2, then we can write them together 7 divided by 3 and combine together by giving the bracket are having power 2. Got it? Let's move to the next one, property number 6. Here property number 6 says whenever the exponent or the power is 0, whatever be the base, the result will be 1. So if you are having 10 to the power 0, the result will be 1. If we are having 1000 to the power 0, the result has to be 1 because there is no existence of 1000 over here. Result is just 1. If we are having 2 to the power 0, the result will be 1. Or if we are having p to the power 0, the result has to be 1. So you must have understood that anything, any alphabet, any number having power as a 0, the result will come out as a 1 only because there is no existence of that particular number or alphabet over there. Now let's move to the next property. Here the next property says a to the power minus m is equals to 1 by a to the power m. So just by switching the place, a to the power minus m can also be considered as a to the power minus m by 1, right? A to the power minus m here is sitting in the numerator, right? So we can switch the place of a to the power minus m and can shift it to denominator. Once it will go to the denominator, the power will be positive. So whenever we are changing the place of any number from numerator to denominator or from denominator to numerator, the power will reverse its sign. If it is already positive, suppose we are having 2 to the power 2. Let's write it 1 by 2 to the power what? The power will reverse its sign. Already it was positive, now it will become negative. When the power is negative, then we will switch the place, we will write it to denominator and the power will reverse its sign. Now let's solve some examples. So as we can see here, we are having one expression and we have to simplify it by using the property of exponents. So as we can see, at first we can distribute the power according to the property which says a by b whole is having power m, which can be written as a to the power m divided by b to the power m. This property we are going to apply at first. So it became 1 to the power negative 2 by 2 to the power negative 2. We have just distributed the powers. Similarly, we will distribute the power for the other terms as well. So it will be 1 to the power negative 2 divided by 3 to the power negative 2. Similarly, 1 to the power negative 2 divided by 4 to the power negative 2. Now, 1 to the power negative 2, 1 having any exponent will be 1 only. So, here we are having only 1 divided by 2 to the power minus 2. Let's write it as it is. Similarly, 1 divided by 3 to the power minus 2, writing it as it is, plus 1 by 4 to the power negative 2. Now we know the property which says a to the power minus m can be written as 1 by a to the power m. That means whenever we switch the place from numerator to denominator or denominator to numerator, the exponent reverse its sign. So this 2 to the power negative 2 is sitting in the denominator. Let's switch it to numerator. So it became 2 to the power positive 2. Alright. Similarly, 3 to the power minus 2 became 3 to the power positive 2 while shifting it to numerator, and 4 to the power positive 2. Now let's add all of them together because there is no property which is having addition in between. So 2 to the power 2 will be 4 plus 9 plus 16 and that will give us 29. and hence it's our final answer. Now let's do the next question. Here also we have to do the simplification. Whenever we are having such simplification, always try to break the numbers in exponential form. So 25 can be written as 5 square, right? T to the power negative 4 is already in exponential form. Let's write the denominator. 5 to the power minus 3 is already in exponential form, and 10 can be written as 2 times 5. Now t to the power negative 8. Now after breaking each and every term, we will search the like terms. So in numerator 5 to the power 2 is there, and there is no more 5 in the numerator. In the denominator we can see 5 to the power minus 3 is there, and here one more 5 is there. So let's combine them together by applying the first property. So 5 to the power 2 times t to the power negative 4 divided by 5 to the power minus 3, and here the exponent of 5 is 1. So we will add 1 over there because both the bases are in multiplication. So negative 3 plus 1 times 2 times t to the power minus 8 is equals to 5 to the power 2 times t to the power minus 4 divided by negative 3 plus 1 will be negative 2 times 2 times t to the power minus 8. Now we can apply the division rule. Why we are going to apply the division rule? Because here we can see 5 square is sitting in the numerator and 5 to the power minus 2 is sitting in the denominator. So one term is in numerator, another is in denominator. That means both are in division with each other, right? So let's apply the property of division. If we are having 5 square divided by 5 to the power minus 2, the result will be a to the power m minus n, where m is the numerator's power. So 2 minus of 2, that means it will give 5 to the power 2, that means 5 to the power 4. So we got 5 to the power 4 over here. Similarly, we will apply the division rule for t also, because t to the power negative 4 in the numerator and t to the power negative 8 in the denominator. So it will become t to the power negative 4 minus of minus 8. And by 2 will be as it is, because there is no more 2. So we will have 5 to the power 4 times t to the power negative 4 plus 8 will be positive 4 divided by 2. And that's our final answer. Now let's do one more question. So here we are having curly bracket, and inside that we are having two terms in subtraction, and after that the curly bracket close and the power is negative 1. So at first, according to the Bodmer, solve the bracket at first. Accordingly, we will solve the curly bracket at first. So curly bracket start. This 1 by 3 to the power negative 1, just like the previous question, we will distribute the power. So we will have 1 to the power negative 1 divided by 3 to the power negative 1. Similarly, minus 1 to the power minus 1 divided by 4 to the power negative 1. Curly bracket close, minus 1. Now, as we know, 1 to the power anything is just 1. So let's write it. 1 divided by 3 to the power minus 1 minus 1 divided by 4 to the power minus 1. Curly bracket close. Now we will make the exponent of 3 and 4 as a positive so that we can simplify it further. So here we are having 3 to the power minus 1 sitting in the denominator. Let's shift it from denominator to numerator. So it will be 3 to the power positive 1, which can be written as only 3 as well, right? And minus 4 to the power positive 1, which can be written as only 4. Curly bracket close. One more power is there. Be careful and write it. Now 3 minus 4 will be negative 1, and negative 1 is having power negative 1. So we are having minus 1 to the power minus 1. Now, as we know, whenever we switch the place, whenever we write any term from numerator to denominator, then the power reverse its sign. So let's write this negative 1 from numerator to denominator. What's there in the denominator? Nothing is there. 1 is there. So it will be 1 divided by minus 1, which can be written as minus 1 as an answer. Now let's do question number 4. Here our question says find m so that minus 3 to the power m plus 1 multiplied with minus 3 to the power 5 is equals to minus 3 to the power 7. So here we have to find the value of m from the given equation. So let's write the given equation. Minus 3 to the power m plus 1 times minus 3 to the power 5 is equals to minus 3 to the power 7. Here we will focus on left hand side of the equation and we will solve the left hand side at first. So let's solve it. As we know, when the same bases are there and both the terms are in multiplication, then we have to add the powers. So it will be minus 3 to the power m plus 1 plus 5 is equals to minus 3 to the power 7. Let's solve it. So minus 3 to the power m plus 1 plus 5, when we will add the constant term, it will be m plus 6, right? Is equals to negative 3 to the power 7. Now, since both the sides are having same basis, hence we can compare the powers. Why we are going to compare the powers? Because there is a equality sign in between. That means the term or the value in the left hand side is equals to the value in the right hand side. That means m plus 6 must be equals to 7. How we will write? We will write comparing both sides, which will give us the value of m as 1. And hence we got the value of m with the help of the given expression. Be careful, we are not cancelling minus 3 with minus 3 because that is not allowed over here. We can only compare both sides due to equality sign. Now let's see how to represent any number in exponential form or also known as a standard form. So the first criteria whenever we are writing any number in a standard form is, after writing it in exponential form, it must be in the form 8 into 10 to the power k, where k can be positive or negative, doesn't matter. So whatever number will be there at the place of a can be 1 or greater than 1, like 1.24, 1.35, anything, but has to be less than 10. All right. Let's understand it with the help of given question. So here our question says the distance from Earth to Sun is given. It's such a larger number and the distance is given in meter. We have to write it in exponential form or standard form. So here at first we need to check where the decimal is sitting. So as we can see, it's a whole number, right? And in a whole number, the decimal must be sitting at last. For example, if we are having 25 rupees or 25.00 rupees, both are same thing, right? So here also the decimal place is here. Now we will shift the place of decimal. As we can see, we have to shift the decimal towards the left direction here. And whenever we have to shift the decimal towards the left, then the power of exponent will be positive. So left direction will give the positive exponent. Let's see how. So decimal will go from here to here, 1 place, from here to here, 2 place, again 3 place, 4 place, 5, 6, 7, 8, 9, 10 and 11. So it is moving 11 places towards the left. Why 11 places, not 10, 9, 8? As we have already discussed, a must be greater than or equals to 1 and less than 10. If we will take 14.96 into 10 to the power something, this 14.96 is greater than 10. If we will take 149.6, again it is greater than 10, which is not acceptable for a standard form. So we will take 1.496. Let's write it. So it became 1.496 times 10 to the power 11. Positive 11 as left direction. Whenever we are moving towards the left direction, the power will be positive. You can also understand it like, suppose we are having the given number and with that we are having 10 to the power 0. As we know, 10 to the power 0 will not give any impact on this number. Anything having power 0 is just 1. So here we are having 10 to the power 0. Now when we are moving the place of decimal, it became 10 to the power 1 over here. When the decimal shifted from here to here. Now again, when we will shift the place of decimal towards left, one more place like this, then it became 10 to the power 2. Similarly, here it became 10 to the power 3. Here it became 10 to the power 4. And like this, we got 10 to the power 11 over here. And hence, we end up getting 1.496 times 10 to the power 11. Now, let's do a few more questions. So, question number 2, again, we are having a whole number and we have to express it in standard form. Suppose here we are having 10 to the power 0. Now, when the decimal is getting shifted from here to here, it became 10 to the power 1. Again, we are shifting the decimal, it became 10 to the power 2. Again, we are shifting the decimal, it became 10 to the power 3. Let's see how many places we need to shift the decimal. So, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. 10 places we need to shift the decimal towards which direction, left or right. So as we can see, we are moving towards left direction. So it will be 3.186 times 10 to the power positive 10. All right, let's do the next one. Here also we are having a whole number. Let's shift the decimal. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we are having 6.02 times 10 to the power 15, positive 15. Now we have worked with such a larger number and we have represented it in exponential form. Here we are having such a smaller number and here also we will represent it in standard form or exponential form. So let's see number 3. So at first what we do, we check the place of the decimal, where the decimal is already sitting. Here we can see the decimal is given in the question. Can you see it? Okay. So we will shift the place of the decimal. Now here when you will see carefully, you will realize that we need to shift the place of decimal towards the right direction. And we must know that right direction will give the negative exponent. So let's see how many places we are going to shift the place of decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So it became 8.5 times 10 to the power 14. But will it be 10 to the power positive 14 or negative 14? It will be negative 14 since we are moving towards the right. All right. Similarly, we will do the next one. So here also we need to shift the place of decimal towards the right direction. Let's see how many places. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 8.37 times 10 to the power 9. It will be positive 9 or negative 9? Of course, it will be negative 9 since we are moving towards the right direction. One more thing we can understand from here, that like the previous one, here also we are having 10 to the power 0. And when the decimal is moving towards the right direction, then this power of 10 is decreasing. Okay, from 0 it became negative 1. From negative 1 it became negative 2, then negative 3, then negative 4, negative 5, negative 6, like this. For the first step it became negative 1. For the second step it became negative 2. Just like this, we have got 10 to the power negative 40. Here also we can assume we are having 10 to the power 0 beside the given question, and when the decimal is moving towards the right direction, the power is decreasing. So we can also write that right direction represent the power is decreasing. and left direction represent the power is increasing. All right. Now let's do few more questions. Here we have to express the given number in its usual form. So standard form is already given and we have to write in its normal form or usual form. So as we know, whenever we were moving towards the left direction, the exponent was increasing, right? We were getting the positive exponent, or we can also say the exponent was increasing. And whenever we were moving towards the right direction, we were getting the negative exponent. That means the exponent was decreasing. Now let's see question number 1. Here we are having 3.02 times 10 to the power minus 6. Now here we are having 10 to the power negative 6. In usual form, we know there is 10 to the power 0 or nothing is there as a power of 10, right? That means we have to come from negative 6 to 10 to the power 0. So when we are moving towards negative 6 to negative 5, negative 5 to negative 4, that means we are increasing. We are increasing the exponent. And whenever we are increasing the exponent, then the decimal must be moving towards the left direction, right? Now how many places towards left? 6 places according to the given exponent towards the left direction. So we are having 3.02 times 10 to the power minus 6. This will be 10 to the power 0 when we will be moving 1, 2, 3, 4, 5 and 6. As you can see, we have moved towards the left direction. Now what we will write at the place of blank? So here we will write zeros. When we don't have any number or digit, then we fill the blank with zeros. Now decimal shifted to here and our number became 0.00000302. And after that, this 10 to the power negative 6 became 10 to the power 0. That means only 1. So we can write our number without this also. Now let's do the next one. Here we are having 3.61492 times 10 to the power 6, positive 6. All right. Here again we will make the exponent 10 to the power 0. Right. From 6 we have to come to 0. So 6 we have to go to 5. Then we will go to 4. Then 3. Then 2. Then 1 and then 0. Right. That means we have to decrease the exponent. And whenever we have to decrease the exponent, we must be moving towards the right direction. Right means this direction. So let's move the decimal 1 place, 2 place, 3 place, 4 place, 5 place and one more place. That means 6 places. So here at last we will be having 1 0. Let's write the answer. It became 3614920. Let's do our next question. So our next question, we are having 3 times 10 to the power minus 8. This minus 8, again we have to make it 10 to the power 0. That means we have to increase the power, right? When we will be increasing the exponent, then we must be moving towards the left direction. So let's write it. 3 times 10 to the power minus 8. And since we are having only 3, we know the decimal must be sitting at last. So from here, it gone over here. 1 place, 2 place, 3, 4, 5, 6, 7 and 8. At the place of blank, we will write zeros. So 1, 2, 3, 4, 5, 6 and here 7. So total 7 zeros we have to write before 3. So our answer is 0.00000003. That's it. Let's do the last question. So here we are having 4.5 into 10 to the power 4. Again this 10 to the power 4 we have to make it 10 to the power 0. From 4 we have to go to 0. That means we have to decrease the power. Whenever we have to decrease the power, we must be moving towards the right direction. So it became 45000. That's it. Now let's do one simplification. So here we will apply the properties of exponents and we will do the simplification. So as we can see, we are having 5.97 times 10 to the power 24 plus 7.35 times 10 to the power 22, which is such a larger number, right? And since here both the exponents are not same, hence we cannot add them directly, right? Because you must have learnt in decimal addition that when we have to add 3.92 with 0.23, so we do the addition 3.92 0.23. Here we will write decimal below decimal, then only we can add both the decimal number. And since here number of zeros and powers everything are different, so we cannot add them directly. So let's make the powers same at first. So here we will try to make both the exponents same, like both the powers should be 10 to the power 22 or 10 to the power 24. Let's keep 10 to the power 22 as it is, and let's make this 10 to the power 24 also as 10 to the power 22. So 5.97 times 10 to the power 24, can we write it as 10 to the power 2 times 10 to the power 22? Because the rule of exponent, the first property of exponent says whenever we are having same basis, we have to add the powers. So accordingly, we can break it also, right? Now this term and this term became same. And since the power is same, we can take it out as a common factor. So let's take it out as a common factor. We are left with 5.97 times 10 to the power 2 plus 7.35. Now we can add it. But before adding, let's write the first term in its usual form. So we will be having 597 plus 7.35. And 10 to the power 22 is already there as a common factor. That means 597. Where is the decimal? Decimal is after 7. It's a whole number. We can write as many zeros as we need. And 7.35. Let's add them. Hence we got 604.35 times 10 to the power 22 is as it is. Alright, and this is our final answer. I hope you have understood the whole concept on exponents and powers. Thank you.